All right, so in today's lesson, we're going to be looking at permutations and combinations and talking about the difference between the two styles of questions. So to start with, what I want you to do is I actually want you to press pause on this video, and then I want you to try all 4 of these questions. First of all, see if you can figure out if it's a permutation or combination. Okay, and then after, see if you can solve the problems. So to start with, I will just write permutation or combination on each question. So the first one, how many arrangements of the word poppies can be made? Okay, so a key word here is arrangements. So as soon as I arrange something, obviously the order matters. So this would be a permutation. So I'm going to write P. A class consists of 5 girls and 7 boys. A committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee. So this question would be a combination, because when you're choosing a committee, the order doesn't matter unless there are specific roles in that committee. The students in a school band have practiced 5 popular and 6 classical musical compositions. For the school concert, they will choose a program consisting of 3 popular and 2 classical. If the order of the compositions matters, determine the number of different programs. So this one's actually a tricky one. So this example, you'd be choosing and arranging. So first you have to choose the popular and classical music, and then after you choose your song selections, you're arranging them. So this would be an example where you would use both. In the last question, Coach Zabar must choose 12 athletes out of 20 that tried out. How many combinations of the teams can he make? So this would be an example of a combination, because once you're on the team, you're on the team. It's the same team no matter what order you pick the athletes in. So we would write 20, or combination, sorry. So now that I've written down which is which, pause the video again and see if you can find the answers for each of these questions. All right, so let's start with the first one here. How many way arrangements? So we already know that poppies is in a permutation. The next thing you should notice is that the P repeats. So that means this is an identical object type question. So we're going to have to divide by the identical objects, which in this case would be the 3 P's. So to start with, let's count how many total letters we have in this question. 1, 2, 3, 4, 5, 6, 7. So my 7 factorial represents all the different letters. And I'm going to divide by the identical letters, which are the 3 P's, or 3 factorial. So on my calculator, I'm going to write 7 factorial divided by 3 factorial. All right, so go ahead and type that in, and you should be getting 840. So there's 840 ways that I can arrange the letters in the word poppies. A class consists of 5 girls and 7 boys. I'm going to use a different color here. A committee is to be formed consisting of 2 girls and 3 boys. Okay, so we already know that this is a combination. Let's start with the girls. So out of the 5 girls, we are choosing 2. And out of the 7 boys, we are choosing 3. So on our calculator, we're going to write 5 choose 2 times 7 choose 3. All right, and you should end up getting 350 as your answer. The students in a school band have practiced 5 popular and 6 classical musical compositions. For the school concert, they will choose a program consisting of 3 popular and 2 classical. If the order of compositions matters, determine the number of programs. So let's choose our songs first. So out of the 5 popular, we're choosing 3. And out of the 6 classical, we're choosing 2. So on our calculator, we're going to type 5, choose 3, times 6, choose 2. So this represents all the different combinations of songs that I could pick. Now I have to arrange them. So I'm going to take 150, and because I have 5 songs that I'm arranging, I'm going to times that by 5 factorial. And I end up with 18,000 as my total answer. That's a lot of different programs. Last question, probably the easiest one out of the 4. So we know this is a combination. We're choosing out of 12 athletes, or out of 20 athletes, sorry, we're choosing 12. So we're just going to type 20, choose 12. Remember, this is the same as 20, choose 8. The reason being is in option A, you're choosing 12, but you're also not choosing 8. Here, you're not choosing 8, but you're also choosing 12. That's why they're the same, and we talked about the algebra in the last question, in the last slideshow, I mean. So we're going to type 20, choose 12, and we end up with, wow, a really big number. So there is 125,970 different teams that you could select. All right, so consider the following when solving counting problems. Are there any restrictions? Are repetitions allowed? Are there identical objects? Does order matter? Are you choosing a group where position doesn't matter? Look out for at least or at most problems. That's when you're going to figure out all the options. And always ask yourself, is this an or an and question? So you know if you're either adding or multiplying. All right, so we're going to look at a few more examples here. A piano teacher and her students are having a group photo taken. There are 3 boys and 5 girls. The photographer wants the boys to sit together and the girls to sit together for one of the poses. How many ways can the students and teachers sit in a row of 9 chairs for this pose? So we have a piano teacher. We have 3 boys, 5 girls. And this is one of the questions I keep meaning to come back and change, but I don't, because sometimes I'll have a student who wants to include the teacher with the girls. But the 5 girls just represents the 5 students. So the photographer wants the boys to sit together and the girls to sit together. So they just mean the students. We're going to count the teacher as like their own separate group. Okay. So first of all, let's figure out how many different ways we can arrange these 3 groups. So the 3 factorial represents the ways I can arrange the 3 groups. Now I'm going to need 3 boys. How many ways can I arrange the 3 boys? So I'm going to times 3 factorial again. So this represents all the ways that I can arrange the 3 boys. And now I need to arrange those 5 girls. So I'm going to times by 5 factorial, which represents all the ways I can arrange the 5 girls. In total, I should end up with 4,320 as my answer. Okay, we're going to skip the one about the cards. We're not going to worry about that. A class consists of 5 girls and 7 boys. A committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee. So we have 5 choose 2 to represent choosing the girls. 7 choose 3 to represent the ways to choose the boys. And we end up with 350 committees. Next it says Johnny, the principal's son, has to be on the committees. So this doesn't affect the way we choose the girls. However, for the boys, now there's 1 less boy to select from, and instead of 3 positions, there's 2 positions that we're selecting. So we end up with 150 committees. The last question, the twins Peter and Paul cannot both be on the committee. So there's actually 2 different ways you could do this question. You could figure out all the different combinations where Peter's on the committee and not Paul, or Paul's on the committee and not Peter, or neither on the committee, and then add them together. Or, probably an easier way to do this, we've already figured out the total amount of committees, which is 350. So we could actually just figure out where they both are on the committee. And then subtract from the total. So, it wouldn't affect the girls. I still have 5 choose 2. But if Peter and Paul were both on the committee, okay, out of 7 boys, now I'd be selecting 5 boy positions because they are already selected. So I'm only selecting out of 5 boys. And because they are both on the committee, there's only 1 seat that I'm selecting now, sorry. So on my calculator, I would type 5 choose 2 times 5 choose 1. And I get 50. So you might be asking, well, the question says that they can't both be on the committee. right? And you found where they both are on the committee. The reason I did that was I can take the total amount of committees, which is 350, subtract where they both are on the committee, which is 50, okay, and I end up with 300. So this 300 represents then all the committees where they both are not on the committee. So it's all the other groups. All right, so let's look at a couple of diploma questions. Again, I'd like you to pause the video and see if you can figure them out by yourself first. That's definitely a lot more helpful than just following along. So the following symbols are selected and arranged. So I'm going to highlight the word arranged. So right away I know this is a permutation because we're arranging. So that means C and D are incorrect. No symbol can be repeated. Which of the following calculations can be used to determine the number of possible code words that can be created when at least 8 symbols are selected and arranged? Okay, so because of that at least, remember this is where we find those options. So we have at least 8 symbols, which would be 8, so out of 10, sorry, there's 10 symbols. I'd be arranging 8 of them. Or 9 symbols, so out of the 10 symbols, I'd be arranging 9 of them. Or out of the 10 symbols, I'd be arranging all 10. Oops. Looks like I wrote a multiplication instead of an addition sign. So you would be adding all these, not multiplying them, because it's an or question. So that means A is the correct answer. All right, let's look at this last question. If 14 different types of fruit are available, how many different fruit salads could be made using exactly 5 types of fruit? So really we know this is 14, choose 5. Okay, if you type that in your calculator, let's try typing it in. You'd end up with 2002. So really you could just try all these other different ways and see which other questions give you 2002. So student 1 had 14 factorial divided by 5 factorial. Would that give you 2002? No. Okay, so we know student 1 is incorrect. Ron suggested using 14p5. So this isn't an arrangement, it's not a permutation, because when you're choosing fruit for a fruit salad, the order doesn't matter, right? As once you pick your fruit, it's in the salad and they're all mixed together. So that's why it's a combination, it's not a permutation. Okay, we've talked about this before. 14 choose 9 is the same as 14 choose 5. And again, you could double check that on your calculator. They both give you 2002. Okay, and then we also, if you remember, we looked at the formula and compared and algebraically showed that they're the same. Jackie thought that 5 factorial would give her the right answer. No, that would mean you're arranging 5 items. And we talked about how this is the same thing. This column is just another way to write a combination. So that means the correct answer would be 3 and 5. All right, that's it for today. Again, I suggest you try some of these questions. This unit, okay, the trick of the unit is learning how to read the questions.